Hi everybody, welcome to the first section in linear algebra, section 1.1, system of linear equation. System of linear equation. So first, linear equation, we have the variables x1, x2 all the way to xn. That is the equation, and of the form a1 times x1, a2 times x2 all the way to an times xn equal to b. B is the constant, and a1 to an are coefficient. So we have the variable x1 to xn, the constant b, and the coefficients a1 to an. And the a1 to an are also usually constant. But that go with x as opposed to the constant by itself, b. A system of linear equation, or just a linear system, is a collection of one or more of these linear equations, but they have to have the same variables. A solution of a linear system. A solution of a system is the list S1 to Sn of numbers that makes each equation a true statement when we substitute those values into the variables x1 to xn respectively. The set of all possible solutions is called a solution set, and two linear systems are called equivalent if they have the same solution sets. So pretty standard terminology is here. A system of linear equation may have no solution, exactly one solution, or infinitely many solutions. So think of three scenarios that we have here. If we have two parallel lines, no intersection, no solution. If we have two lines that intersect at one point, that is one solution. And if we have two lines that are on the same line or coincident, then we have infinitely many solutions. So we have no solution, one solution, or infinitely many solutions. A system is said to be consistent if it is either one solution or infinitely many solutions. So these two cases is consistent. And inconsistent is no solution. Right. Matrix notation and system of equations. So in this class, most of linear equation, the system of linear equation, we will use the matrix to solve it. There will be a lot of different ways to solve it, but most of them we learn here. We use matrix. So what is a matrix? So a matrix is a table or a two-dimensional array, and so we call a matrix is a rectangular array. So meaning it have rows and have columns. And the matrix that consists of the coefficient of the system is called a coefficient matrix. An augmented matrix is the system consists of coefficient matrix with an added column of constant on the right side. The size of the matrix tells how many rows and columns it has. Alright, so we have the coefficient matrix and augmented matrix. So I just look at one example here. A simple one. Let's say just two equations. 2x plus 3y equal to 7, and 5x minus 3y equal to minus 2, right? So we have the system of two equations. So if we want to have the coefficient matrix, we're just going to write all the coefficient and put that in a matrix. And this is a coefficient matrix. By the way, some other books, instead of using the square bracket, they use the parentheses as a matrix, so like that. But I write using the square bracket, so it's more organized. And we just leave some space in between the entry. We do not put a comma or anything in between. Just like that. For the coefficient matrix, just matrix. Now, augmented matrix is a coefficient matrix with a constant. So we will write augmented matrix two, 3, 5, and negative 3. If that is the matrix, then it is coefficient matrix. Augmented matrix, I will draw a line here just to separate between the left hand side and the right hand side of the equation. So the augmented matrix will be all the coefficients on the left hand side and the constant on the right hand side. This is called the augmented matrix. Right. Simple enough. Right. More samples. Write the coefficient matrix and augmented matrix for this system. Right. So before we do that, this one has 3 equations, so we're going to have 3 rows and 1, 2, 3 variables. The coefficient matrix will have 3 columns. The augmented matrix will be 1 more. That will be 3 rows, 4 columns for the augmented matrix. Right. So coefficient matrix. Coefficient matrix. Is going to be a 3 by 3. The first one will be the coefficient for x1, 1, 2, and negative 4. Right? Of course not. The first one is the coefficient for x1, and then there's no x1 in this equation, so we're going to put 0 for it. Next, for x2 we have negative 2 for the first equation, and then 2x2, and then 2x2. Right? So, and then for x3 there's 1 for the first equation, and then negative 8, and then 9. That is the coefficient matrix. So once again, 1, negative 2, 1, no x1, 2x2 minus 8x3, negative 4x1, 2x2, and 9x3. That is the coefficient matrix. The augmented matrix. Augmented matrix will be just that. Plus the coefficient, the constant on the right hand side, 0, 8, and negative 3. Right. So a system of linear equations can be written as a coefficient matrix and augmented matrix. Of course, system of equation can be written to a metric matrix, so we can have the constant. So we can go from the system of equation to the matrix, and from the matrix back to a system of equation. Right. Now, how do we solve a system of equation? There's many ways to do that, but this is the most fundamental. It's just substitution or elimination. Elimination usually will be more general, so I will go with elimination here. So this is just equation. I'm going to copy the equation x plus 2y equal to 3, and then 4x plus 5y equal to 6. So those are the two equations, right? Now elimination. To elimination, we can either eliminate x or eliminate y. On this problem, it is easier to eliminate x simply because we multiply something top and bottom to cancel. So we have 4x on the bottom. It is easy to make to have 4x on the top. So in that case, I will multiply by -4 on the top on the first equation. When I do that, we have -4x -ay equal to -12. Yeah, I would only want to use half of the page. The other half we will redo this problem differently. So top equation multiplied by -4. So we have -4 that will cancel with it is 4x. Right. Now when we have those two equations, if we add side by side, -4x and 4x cancel out. -8y and 5y, that's -3y. -3y equal to -6. Now we just have one equation, one variable. It's very easy to solve for, right? Divide by -3 on both sides. We have y equal to 2. Right, so we have y. And then we just substitute back in one of these equations and we solve for x. Now if we substitute this back into the top equation, so I'm just going to say y equal to 2, and we will substitute into the equation x plus 2y equal to 3. So I substitute y equal to 2, and here we have x plus 2 times 2 equal to 3. So x equal to 3 minus 4 is -1. So in this case we say the solution and the solution set, because this set only has one solution. So we say solution x equal to -1 and y equal to 2. Right, so that was the way we use this back in simple algebra. Right, now how do we use the matrix to solve that? Like I said, many different ways to do it. This is the basic. Before we learn how to use the matrix to solve the equation, of course, first we can write that as the augmented matrix. That easy. Right. So what can we do when we have the matrix? Well, when we have the matrix, there will be this elementary row operation. So there will be 3 operations. First one is replace one row by the sum of itself and a multiple of another row. So meaning we multiply a row by a constant, add to another row, replace to that same row. So notice that RJ and RJ here will be the same. This is easy, interchanging the two row I and row J interchange. And finally, multiply all entries of a row by a non-constant. So a row 1, a row I, multiplied by K, whatever we have, start to row I. So those are the elementary row operation. And then we say two matrices are called row equivalent if there is a sequence of elementary row operation that transform one matrix to another. And most importantly, if augmented matrices of two linear systems that are row equivalent, if we have two augmented matrices are row equivalent, they will be the same solution. Meaning that if we have a matrix, an augmented matrix, apply those three operations, we will have the same solution. So we're trying to simplify the augmented matrix using these three operations. And right now, just the first example, we will not do much in this section. The next section, though, we will have the more systematic way to do it. But now we just follow what we did here. All right, first, let's write this as an augmented matrix. So I will write this as an augmented matrix. 1 for x, 2 for y, and 3 for constant. 4 for x, 5 for y, and 6. Right. So what we see here is, of course, first, of course, we eliminate x. So we eliminate x. That means if we eliminate x, of course we have nothing here, turn that to 0. So we multiply -4 into the first row and then add to the second row and replace to it. So just bear with me now. Like I said, in the next section there will be more systematic way to do this. But for now, what we do is multiply -4 to row 1, add to row 2, and replace to row 2. To do that, we eliminate the 4 here. Right. So this is the first section, so I will go extremely slow. -4 times row 1. This row multiplied by -4. So we have -4, -8, and -12. And then we add to row 2. We have 0, -3, and -6. This is going to be the new row 2. So I will write the matrix 1, 2, and 3. I don't do anything with row 1. Row 2 is going to be this new 0, -3, and -6. Right. Next, we have -3y here equal to -6. If we write this, if we're going to write this, it's going to be -3y equal to -6, right? That is equivalent to that row. So of course, to solve for y, we divide by -3. Instead of divide by -3, we can multiply by -1/3 to row 2 and store into row 2. Right. So do that. Row 1 will be the same, but row 2 will be this row multiplied by -1/3. So if we multiply this by -1/3, that gives us y equal to 2. Of course, we multiply everything by -1/3 here. Like I said on the first section, I will go extremely slow, but later on we can do things quicker. So we have 0, -3, -6, that, and then we multiply by -1/3. So 0 times -1/3, 0, -3 times -1/3, that is 1. and negative 6 times negative 1/3 is 2. Alright, so from here this equation is equivalent to 0x plus 1y equal to 2. So indeed we have y equal to 2. Right. So of course after that we can just continue using the substitution here. However, we continue with keeping the matrix. So if somehow we eliminate these two, then we have equation of 1x equal to something. So to try to eliminate these two, like I said, in the next section we'll learn how to do it. But I will multiply by negative 2 into row 2, add to row 1, and store into row 1. So whatever we add to row, whatever row we add to, we have to replace in the same row. So this will be the same. It's just the way it works. And of course we can do this on the calculator as well. Right. So negative 2 times row 2 give us 0, negative 2, and 2. Negative 4, sorry. And then add with row 1. That gives us 1, 0, and negative 1. So that will be the new row 1. So when we do that, we'll have new row 1, 1, 0, negative 1. And then row 2 will be unchanged. So that. Now, this augmented matrix is equivalent to x 1x plus 0y equal to negative 1 and 0x plus 1y equal to 2. Of course the solution will be the same, but this we do using the matrix form. And of course when we use it, we don't need to do the scratch work. We just go with the row operation and then just perform the row operation like that. Right, how do we use a calculator? Right, so first depends on what calculator you have. You might have the TI-83 or the TI-84. They will have similar function, but the displays, the user interface will be different. If you have the TI-83, we will do this second that button matrix, and we will go to this screen. We have names, the first one to recall the matrix, and math to do the math with the matrix, and edit here to input the matrix. So let me write this down. Like I said, this is only when you use in the TI-83 or the TI-84 without the new operation system. So we have names, math, and edit. So that is where we hit the button, the second button, and the x to the negative 1 button. Second, x to negative 1. We have 3, the windows that have 3 tabs here. This one is where we input the matrix, and this is where we recall the matrix. And the math here, of course, obviously we will do math with the matrix. So and if we want to quick second mode, to quick second mode. Right, now second matrix, go to that. First I'm going to enter the matrix here, 1, 2, 3, 4, 5, 6. So I will have to go to edit to input the matrix. Right, hit enter. Now the matrix A. This matrix has 2 rows, 3 columns. 2 rows, 3 columns. Enter the numbers. 1, enter, 2, enter, 3, 4, 5, and 6. Right. Once we're done, second mode. Let's try this again. Second matrix. Now this time you see we have the matrix that have 2 rows, 3 columns, and of course we can work with that. This is the matrix A. Right. So we have the matrix A in the calculator. Now we're going to multiply -4 times row 2 plus row 2, -4 times row 1 plus row 2 into row 2. In the calculator, the syntax will be this. We multiply a row and then add. We will multiply -4 into matrix A to row 1 and then add and replace to row 2, which is 8. So equivalent to this operation, this is going to be multiply a row and then add. So we multiply by k to the matrix. I mean, this is just the syntax of multiply k to row I and add and replace to row j. So on the calculator, we're going to enter that. Right, so second matrix again. Of course, the math is where we have all those operations. It is all the way at the bottom though. So in that case, usually I just go up. Right, multiply something to a row and then add. So what we do is multiply -4. Notice if we use the negative, use this negative. Do not use that subtract. Subtract is between two numbers. Negative is in front one number. We multiply that into second matrix. And under names, this is where we record the matrix. Hit enter. And then comma. Multiply to row 1 and add and replace to row 2. We'll do that because we have this matrix. Next, multiply a number into a row, add and replace to it. So if we need to do that, that will be the syntax on the calculator will be multiply a constant to a matrix and the row I of the matrix. So in this case, it's going to be multiply -1/3 to the matrix and then row 2 of the matrix. Right, now under math, go up, that is multiply a row plus this is multiply a row only. Right, I multiply by -1/3. Now the matrix, if we put A, we cannot put A. A is the original matrix. We just have to use this. So to do that, we will hit second answer, meaning whatever we just have there, we're going to apply to that matrix. So it's going to be answer, meaning what we have, what we just have, and that row 2. And that we have here. And finally we do this one. So multiply -2, answer row 2, add and replace to row 1. So second matrix, go to math and multiply row plus multiply -2 to the last matrix here. Row 2, multiply to row 2 and add and replace to row 1. And that's what we have. So that's what we use the TI-83. We store the matrix and then we just keep going. Only the first one is stored to the matrix A. After that, replace with the answer. So this is what we have. Just pull in to the next one. Right. So that is where we use the TI-83. Now the user interface on TI-84 more friendly, but still do the same math. So I will hit second matrix. I don't even need to store. Just go ahead and jump right into it. I'm just going to do this. Math. And so I'm just going to do that. -4, comma. Now I can enter the matrix in this step. Instead of enter A, instead of enter into the matrix A, just enter the matrix directly. To do that, I hit alpha and zoom. By the way, if your calculator, when you hit alpha zoom and nothing happened, that means there's no option to do this. But when I hit alpha zoom, is what I see is a matrix that have 2 rows. That's good. 3 columns. Okay. Now, the difference when we enter the numbers here and the number into in this form is that when we put the numbers here, do not hit the enter key unless we're done, right? So at 1, I will hit this button to go to the next matrix, the next entry, and then 3, hit next, 4, 5, and 6. So that is the matrix A, right? So multiply -4, apply to matrix A, multiply -4 to row 1, replace to add and replace to row 2. Alright. See, everything will work on the home screen. We don't have to store the matrix into A. Next, I'm going to do that. -1/3. I can hit second answer, which is what we have here. Or if you want to be even more precise, just go up, highlight that matrix, hit enter. Can we do that? No, it does not. I thought we can copy and paste, but we couldn't. So just hit second answer and store into 2. Yes, and then we just enter that. It's the first section. I will have to do all of this step. After section 1.2, we just skip off this and go to the final state. But just need to know how to do this. Right, multiply -2 to row 2, add and replace to row 1. Right, and we have that. Right, so that's how we use the calculator to do the row operation. Right, next we have a few examples here. Is 342 a solution to this system? So by definition, we just substitute that into the system. If it works, it works. Right, so we're going to put 342 into x1, x2, and x3 respectively. Right, simple enough. 5 times 3 for x2, 1 minus x2 is 4, and 2 times x3, 2 equal to 7. Alright, so 8, I'm sorry, that was 15 minus 4 plus 4. And of course, right on the first one, it is not true, right? Put 3 in here, that 15 minus 4 plus 4, so it's not true. So if it's not true, then we don't have to go any check any other equation. So we just say no, because if it works, it has to be true for every equation. So this will be a no. So that is not a solution to the system. Right, next. For what values of h and k the following system consistent? So what consistent mean? Consistent meaning that either it has one solution or infinitely many solutions. Right. Let's put this in the matrix and see, or we just use the elimination. Let's see, yeah, elimination then. So 2x1 minus x2 equal to h. Negative 6x1 plus 3x2 equal to k. Elimination. So we can eliminate x1 or eliminate x2. Let's eliminate x1. We need to have something that has the least common multiple of these two will be 6 or negative 6. So we just multiply by 3 there. That will become 6. We cancel with this 6. When we do that, we have 6x1 minus 3x2 equal to 3h. And then I copy the second equation. 6x1 negative 6x1 plus 3x2 equal to k. Right. And now we just add side by side. That cancel out the x1, x2 cancel out too, so we just have 0 equal to 3h plus k. Right, so 0 equal to 3h plus k. So let's go back. If it is the system is consistent, if it has a solution. Now, when we combine the two equations, we have this. Now, if this is true, we have a solution. If this is false, or because there's no x1, x2 here, so if this is either true or false. If this is false, no solution. If this is true, doesn't matter what x1, x2 is, it will be true. This will be, if this is false, doesn't matter what x1, x2 is, it's still false. So we need this to be true for it to be consistent. Right, so we need this to be true, so 0 equal to 3h plus k. Of course, we can solve for k on term of h. So when we do that, we have k equal to negative 3h. So when this is the case, this is always true regardless of x1 or x2. I mean, doesn't matter what x1, x2, the equations will work, and therefore we have infinitely many solutions when k equal to negative h. But at least, it will be consistent. Right. This example. So we have this matrix. Perform the row operation in successive in this order. So first set swap row 1 and row 2. So that's easy. Just swapping the two rows. 1, 4, 3. And 2, negative 5, and 7, negative 2, 0, and 4. Yeah, just swapping row 1 and 2. That's simple enough. Right, next we do this operation, meaning negative 2 times row 1 times negative 2 give us -2, -8, and -6. Add and replace to row 2. Zero, -13, and -1. I mean +1. So that will be the new row 2. So only row 2 will change, right? So meaning 1 and 3 will stay the same. And this row will go into 0, -13, and 1. Alright, let's use a calculator. Alright, so we have the matrix. Let's just say alpha and zoom, 3 rows, 3 columns. 2. If you hit enter, that will be wrong. Like I said, when we enter this home screen, do not hit enter when we're done. So 2, hit the next button, -5, 7, 1, 4, 3, -2, 0, and 4. We're done. So hit enter. Alright, so we have the matrix there. Good. Now let's swap. We haven't done any swap for row, so I just want to show you second matrix. Go to math, and we just go to the row swap. We're gonna, and we will swap row 1 and 2. Right, so we swap that, and this is what we have. Right, now we're going to do this, which is, just write the syntax one more time. Multiply 2 of row and then add. Multiply -2 into the matrix, whatever we have from the previous stage. Multiply to row 1 and add it to row 2 and replace to row 2. Oops, this one. Multiply -2 to the matrix, add it to row 1 and replace to row, add it to row 2 and replace to row 2, sorry. Right, 1, 4, 3, 0, -13, 1, -2, 0, and 4. Right. So that is section 1.1. Of course, it's just terminologies. We spend a lot of time just to go over how we do use the calculator, because in this section we need to know how to do this on the calculator. And don't worry, when we get to section 1.3, we will do just jump straight from that into this. But first 2 sections I want to go very slow, and then we do every step in different ways. Just make sure that we have everything. But that's the end of section 1.1. See you in another video in linear algebra. Thank you for watching.